Francesco speaking. Okay. Hello everybody again. Welcome to this webinar. Yes, you are muted. You should have any question or comment. Let me know in the chat. But for the moment, if there is no specific question of okay, let me do a check. So one is not hearing. John Muge, can you hear me?
Yes, I can hear you fine.
Okay. Okay. Okay, so let's start. Other people are joining in the meantime. Okay. Sorry for this little inconvenience, but okay, you should be able to see the presentation on the screen. Let me check. I will use you, John, as a check. John, can you see the
Yes,
first page of the presentation?
Yes, it's displaying fine, thank you.
Okay, welcome again. This is the Automotive Telematics Infotainment webinar organized by Open Mobile Alliance. Welcome to the speakers that kindly accepted to be here, and welcome to all the attendees registered for this webinar. Let me provide you a brief introduction on this topic. As we all know, a significant challenge for the near future, for the future that is coming, is the development of the machine-to-machine. that represent a massive market opportunity for the mobile operators to provide machine-to-machine services, for example, enabling machines to talk to each other and be managed. The overall, the complete machine-to-machine market is quite large. Indeed, it encompasses a broad range of applications, including automotive telematics, that is the topic that we'll discuss, but also others such as smart metering, smart cities, and so on. The connected cars, even driverless cars, might not be so distant in the future as we may think. For example, if you imagine, let's imagine that you are driving a car, for example, and a message is projected in your windscreen warning, for example, that an accident just happened around the corner. Or for example, imagine a connected smart car that is able to show a 360-degree view of the area around your car, using sensors to scan for other vehicles, animals, objects, or whatever is happening around you. And also maybe, for example, using a smart cruise control, also able to communicate with each other cars through a vehicle-to-vehicle communication technology. So these use cases that we may think may happen in the very near future. This trend is commonly usually named as Intelligent Transport System, or ITS, that we may summarize in a few words that it means applying communications and computer technology to transport. In our cars, but not only in our cars, in all the vehicles that we have on our roads. Today there is much more technology than ever in the past, especially related to safety, but not only. Automotive, indeed, not only safety related aspect. For example, I took a note here at the last Mobile World Congress. The president of the Ford Europe, Stephen Odell, in his keynote said that the cars are the smartphones of the future. There are many untapped opportunities for mobile to play a role in advanced automated driving. So this is a very strong sentence. Consumers are already started to expect their cars to be connected as their phones. This is a very significant expectation from the consumer, and many experts in both the mobile and the automotive industries are confident that the technologies will evolve to create a completely new relationship between the drivers and the cars, new that probably we are not able to imagine in this point of time. There is a prediction, one of the several predictions that are available, in particular for the firm SBD, that predicts 21 million cars in 2018 that will be sold with a smartphone integration systems. So a significant revolution because such cars will be able to provide the right information at the right time. And one of the most exciting aspect of connected car is probably also the opportunity to extract data from the vehicle in real time. But extracting data is not everything, because another opportunity is personalization and profiling also of the car behavior or profile, depending on who is driving the car. Finally, connected, I mentioned connected car, of course, means connectivity. Connectivity means a technology to be connected. So in terms of connectivity technologies, LTE will be probably the main connectivity solution, especially when the vehicle is in motion, because there are alternatives such as Wi-Fi, but these other connectivity technologies may make sense when the vehicle is parked. For example, may be used for functions such as software updates, downloading of maps, content downloading, and so on. But we are just at the beginning to explore what is possible with the connected cars, and many other scenarios, use cases, and level of innovation are just around the corners. So let's start with this webinar hosted, organized by OMA. A few words about OMA for who is not familiar. OMA, Open Mobile Alliance, is a consortium of leading industry for the telecommunication market, operators, device vendors, and infrastructure vendors. And OMA is the reference organization for the production of the so-called service enablers. The service enablers are the specification package that may be used may be implemented by the mobile operators to build, to create final services for the end users. So OMA has developed many specifications, many service enablers, and also APIs in several areas, such as communications, content delivery, device management, machine-to-machine, and location, just to mention a few. Okay, we are here ready to start. First of all, I would like to thank all the speakers that kindly accepted to be here to present at this webinar, and also Eshwar, that is the OMA Marketing Director, for the support on organizing this webinar. With respect to the agenda that you see on the screen, we had a little change. Joel from Intel will be the second speaker just after Russell. So enjoy the webinar. Let me open the presentation from Russell. Okay, you should see the presentation. A few words about Russell. Russell Shields is the chairman of YGOMI in 2008 to recognize his 40 years defining new industries. The University of Chicago Booth School of Business awarded him the Distinguished Alumni Award in Entrepreneurship. He is a board member of the ITS World Congress, was a founding board member of ITS America, former chairman of the TRB Communications Committee, and former convener of ISO TC 204 Working Group 16. Is now chairman of the ITU Organized Collaboration on ITS Communication Standard. He received the 1998 SAE Delco Electronics ITS Award and was named as an SAE Fellow in 2007. Was inducted into the inaugural class of the ITS America's Hall of Fame in 2008 and was named the inaugural U.S. member of the ITS World Congress Hall of Fame in 2010. So, welcome Russell, and I will open your microphone. Okay. Please start with your presentation, Russell. Thank you.
Okay. Thank you very much. Long introduction that just says I've been around ITS for way too long, causing lots of trouble as we push forward. So I'll try to give you an overview of where I think things are currently and move forward on that. I guess you should go ahead, and I'll tell you when to go to next slide because I don't have control. So why don't you go to the next slide. Okay. The basic thing is we've worked on communications with vehicles for now more than 20 years. The challenges continue to be there, but they are certainly much less than they used to be. And I have the hope that over the next half a dozen years or so, we will finally get to where we want to be. Built-in NADs clearly provide better service for people, have lots of advantages, but cost has been a problem. Figuring out the structure that will allow a really true multimedia offering, not just a simple telematics, has been worked on. There's processes we're moving, but we still have limits. Certainly the flexibility, being locked into a carrier for life of the vehicle, 15 to 20 years, is not where car companies would like to go, but has been basically the structure so far. Even more important right now is cars are sold all over the world. Currently, there's no worldwide SIM structure that's straightforward, so you need to have different SIMs in different markets. Monumental manufacturing mess for car companies where they are selling cars in 150 or more different countries. So doesn't fit into mass production. So various of the efforts that will get an updatable SIM, soft SIM, that's been worked on by parts of the mobile industry, and hopefully through activities with GSMA or OMA or others, but mostly the GSMA right now, will finally get us a solution that we can truly be able to move forward with in meeting the car industry. And that's obviously for carriers an interesting challenge, because though cars are sold around the world, so far we're nowhere close to having carriers around the world, and I'm sure that will not change in the foreseeable future. Okay, next slide. Okay, so we've got now a mishmash of driver's phone being used from some car companies. The services are okay, but they're not where we really want to go. There's plenty of trouble with even getting basic Bluetooth connectivity working for all phones with hands-free. Adding it with a complicated data plus voice has made it even harder. Obviously, some cases, customers have been surprised by substantial increases in their amount of data. I've seen cases with people not understanding even simple applications like Pandora and suddenly finding out when they were driving a lot in a month that it was a big increase in their usage. There's, I think all of you know, campaigns on to look at driver distraction. Various parts of the world have at least banned texting by phone. They haven't updated all of the activities to handle many of these things. Some countries have stronger HMI rules than others right now, but there's a consistent effort in the UN organized cooperation on automotive regulations to see how to get progress and consistency in areas. Obviously, we've got Apple CarPlay that was announced in Geneva Motor Show a month ago that will be in some cars at the end of the year. Google announced their cooperation at Consumer Electronics Show. These kind of things will do a better job of integrating with the car for the specific type of phone, but is restrictive in the longer term, even for car companies that right now are planning to put both in their cars. They still, besides that cost, do have issues as people have Windows phones, Mozilla working on things, many different Chinese smartphone efforts that can lead to different things. So it's an issue. Next slide. With the mobile phone connectivity, using the phone at least as a modem, there's the efforts on running the apps on the phone. That has surprised people on how hard it is. The effort led by Nokia for Car Connectivity Consortium, Maralink, has been struggling to get enough phones even supported. Ford is an example listed here where the Ford Sync is spending a lot of money to test and work on making the phones work. In addition, some of the applications that you would like to have don't have the vehicle data. For example, an application of where is the lowest price for gas around works much better when it knows that the car is in a position that it's going to need to get gas in the next few miles. HMIs and branding is a continued concern by the car companies. They look at their cars, which even in developed countries $15,000 US is pretty much the low end, and lots of cars are sold for $50,000 to $100,000. The branding and structure and what have you has a completely different level of complexity and interest than even the highest end smartphone that's well under $1,000. So it's a different kind of structure. Next slide. Okay, so obviously you can tell from this that I really want to see us get to the point where we've got the communications capability built in. Obviously that gives things much safer and certainly much better applications. You're getting larger screens, special screens, heads-up display, many other things that can be worked on that. The vehicle information is able to be accessed, CAN bus and other things to know status of the vehicle, where it is, what it's doing. Security is a big issue everywhere in the vehicle communications for both the vehicle communications as well as the mobile phone communications. We worry about firewalls and structures, especially since with an integrated NAD and decent connectivity, car companies will move to updating the software in the car over the air step by step, and that's a significant issue since a substantial proportion of the vehicle problems where recalls have people come back into the dealer to get things fixed, their software, and being able to eliminate the software updates in the dealer really will improve safety, because all people will get the updates, not just the ones who read the notices and actually came in. It will get it done much faster and will certainly reduce the cost. Now, in the introduction, Francesco talked about the automated vehicle, made a statement that it may be faster than people think. I fully agree with that. We're involved in efforts that will have automated driving in production cars in the 2020, 2021 timeframe on expressways. And as an absolute core part of that will have to be the capability to use over-the-air communications for, they talked about things like updates. If I've got a car that's automatically driving and somebody figures out an algorithm can be improved to make it safer, or an accident happened because there was some bug and you need to fix the bug, you got to be able to send that over the air immediately. In addition, the basic expectation for a number of years, and that's where I'll use the word automated driving, not autonomous driving, for automated driving, which is a NHTSA level 3, will be on expressways. We reasonably know how to do that, but it will require the driver to pay attention, because at any point, if something unknown shows up, it goes to a very complex junction, or you're getting ready to exit, the driver has to take control. So the requirements will probably say that if you want to go into automated mode, you agree that the camera that's up by the rear view mirror that's looking at you will make sure that you're using the vehicle system, and while you're using the vehicle system on what will be a nice big display, 20 inches wide or other things, you can watch your movie, do your email, use Facebook, etc., but only on the vehicle system, not on your tablet or smartphone, because you have to be aware so that when we need to have you take over, we can flash red on the screen and beep at you and rumble the seat and what have you. So these are all pieces that we're coming towards needing a real solution on how we can get effectively worldwide built-in NADs with a acceptable SIM structure that can last for the life of the vehicle. Next slide. Okay, obviously companies are in this to make money. The car companies are in it to make money so far. They've had real troubles with business models to make money in telematics. They have to work on those. The carriers obviously want to make money, and that's how together real work needs to be done to make a really good solution work. There is now emergency call mandate coming in Russia and the EU over the next 3 years, which will require having a built-in SIM. The emergency call messages are minuscule in data amount, and in most cases those are required to be provided with no cost, but the rest of the use of the SIM will certainly have a cost. The vehicle manufacturers, I think, want the solution that's worked. They've tried various things. Dual SIM has not worked well. There's been some experiment of having the car be part of a family plan, still early in trying to figure out all of that, but there's certainly the idea that maybe a carrier that provides the SIM for the car that is much cheaper if it's part of a family plan can get some car purchasers to switch to their service in for the other mobile devices that the family has. And obviously there's all kinds of thoughts and discussions and what have you of the structure that really says a built-in NAD is similar to a smartphone or what have you, and what should be the subsidy structure that goes with that. All of these things haven't been worked out, are under continuous effort, and will need to be. Excuse me, figured out soon. Okay, next slide. Okay, where do we go? Efforts, GSMA effort with automotive has made some steps. In the new go-round is under change as it tries to figure out how to move forward. OMA is clearly an example of an area, an organization that can help towards moving these things forward. We have to figure it out. as we move. Once we figured out how that is, the ability to move the applications to be car-related, think really about cars, think through that the cars are going to last for a very long time versus a mobile phone, so you have to look at how you can do continued updating and continued structures. So that's there. And the overwhelming top issue is financial and figuring out how we get a good solution that makes economic sense for car companies and their drivers, makes economic sense for the carriers, and works to be really a win-win thing. So should be last slide. So open as Francesca wants to figure out what to do on questions, and hold those for later or take them now. That's my presentation. Thank you, everybody, for listening.
Thank you very much, Russell. So if there is probably there is an echo, I will mute. Okay, you are muted for a while, Russell. If there is any question, I will ask for question, just maximum a couple of questions just after each presentation, but in any case there will be the possibility to ask question at the end of the webinar. So let's see if there is any specific question for Russell now, or as I said at the end is okay the same. I see one. I see one question. Let me try to open the microphone if it works. So from Marcelo Barros, so you can ask your question directly. Marcelo, welcome. You should be able to ask your question directly if you want.
Okay. Good morning, Rousseau. I'm a little bit concerned about if this environment in our next future cars will be, if it will be possible to build my own application or to have a special software company working in this market. Or do you believe that this market will be closed only to car manufacturers?
Okay. Thank you very much. I will reopen the microphone for Russell. Okay, Russell.
Okay. Yeah, that's the ability and how applications get developed for the car is a really difficult consideration, and for car companies who are selling their cars in 100+ markets, they certainly know that they need third-party people to be able to develop them. They also know that there'll be more and more restrictions on what can be done in a moving car that's not in automated mode, and that applications that are aimed for that will have to be very carefully done. On the other hand, for the structure when it is in automated mode, then basically it's open season for whatever the driver wants, and that will have clearly basic ability to access internet, download things, etc. And that has a huge concern on the security and how we work with the same connection that will allow somebody to go out to the internet and pick up whatever bug, Trojan, virus, or other things, and use that exact same connection to be able to download updated software that controls how the car will stop, turn, etc. That's a very, very serious effort. ITU in its effort on security is starting to tackle the security problem. So if we solve the security problems right, then there'll obviously be opportunities for application providers in the car.
Okay. Thank you very much, Russell. There is one more question from Seth. Seth will open the microphone so you can directly ask your question. Go ahead,
Yes.
Seth.
So, Russell, thank you. Great presentation. Is there, in the same general topic that the prior questioner asked, do the car companies have any kind of concept of something like an app store that would allow the owner to customize the car, or do you view that this will be a completely closed system? Thank you.
Okay, Russell, your microphone is open again.
Definitely car companies will have something that is equivalent to an app store. One simple example, Infiniti Q50 that's on the market now that we provide the capability. Nissan Infiniti calls it an app garage to make it clear that it's not the same as the Android marketplace or what have you, but it has in it applications, and the expectation is working with various providers, a number of which in Silicon Valley as well as in Japan right now are being worked on. A prototype will be added to that app garage to allow downloading new applications, and there's already been a series of releases updating applications for new capabilities and new functions that can be downloaded to the car.
Okay. Okay, thank you very much, Russell, again for the very good presentation. Stay with us, of course, if you can stay with us until the end. Let's go to the next. The next is Joel Hoffman from Intel. Let me open, let me give to Joel the control of the screen so that Joel will be able.
Yes, I'm here. I think you unmuted me. That's good. And now I'm going to share my screen. You can go ahead and make the introduction while I try to open up the display.
Okay, great. Thank you.
It takes a few minutes, or a few seconds. Let's see. Here we go. Okay, very good. I'm ready to go.
Yes, Joel from Intel. Thank you very much also for you for your presentation that you are going to provide. Is the automotive strategies for Intel's expanding automotive solution division. In this capacity, he leads the strategic focus for the next generation of automotive use cases, providing direction for silicon development that applies to cars several generations into the future. He also drives the infotainment group toward a common and open vision, which includes spearheading new market development around advanced driving technologies. Pioneering the open software innovation, Joel has been involved in the GNV Alliance. That is a non-profit industry alliance committed to driving the broad adoption of an in-vehicle Infotainment, IVI, open source development platform, since its inception in 2009. In addition to developing its original name and branding concept, he continues as a board member, leads the marketing team, and is treasurer of the Alliance. With a background in sales and marketing and technical experience in automotive, telecommunications, and consumer electronics, Joel represents Intel in a variety of automotive contexts as the company invests in this important industry. So, Joel, yes, it's your turn. Thank you.
Oh, well, thank you very much, Francesco. And thank you to the audience for attending today. I'm very happy to be here on behalf of not only my role in Intel Corporation, but most prominently in this context, I'm speaking on behalf of the GNV Alliance. And as Francesco mentioned, I have been involved since the inception. In fact, we really started working together with a few key automotive players, if you will, back in 2006, 2007. At that time, there was no concept of any software in the central portion of the display. As you look at the picture, we're all familiar with expecting now to see a little TV screen, if you will, in the middle of our car. The software that is developed to work behind that has always been proprietary, and as a result, very, very expensive to develop. And each car model, each car make, each car brand was created uniquely. So it was clear that that is not a scalable model, and it is also clear that we can't advance fast enough in innovation if we continue down that path. So we got together with substantially with BMW and Intel and Wind River and a few other suppliers to put together a model that we thought would change that environment. And we're not talking about everything about the way that the head unit is designed in the hardware side. We're talking mostly really about the software. And what that became was this industry alliance that we call the GNV Alliance. GNV, taken from the city of Geneva, some example of international world peace, if you will, because we know that the competition between suppliers and the competition in these really quite expensive consumer devices that we call cars is aggressive and is justifiably so. So we need to find a way to get along or to share a common purpose and a common outcome or deliverables. So we laid out this mission and this purpose, and the deliverables really are to come up with alignment across the IVI specific requirements. And in that context, to use an open platform, namely the Linux platform, was really the only option that existed. Any other platform would force us into a commercial model with licensing and with financial obligations that would basically negate the benefits. So we went out and we offered this up to the industry, and amazingly, not really totally amazingly, but really kind of to our own surprise, we got tremendous response. It's clear that the industry is looking for an open solution They're attracted to the idea of utilizing Linux in the car. I think this slide says a lot in the sense of the number of members, but it also says a lot in the sense that every single car Tier 1 is involved in Geneva. Some more than others. Clearly, some are standing on the side and looking to see what's going to happen, but others are investing their entire business strategies around Geneva. And that's surprising in a way, because some would have thought that, you know, the concept of putting an open platform for software would be a great advantage for the car OEMs, but it would potentially be taking business away from the Tier 1s. But we have found that it actually has opened up new business opportunities, and those new business opportunities are coming to the members of the Geneva Alliance. So let me give you a quick little snapshot of what we do and what the focal points are for the Geneva Alliance. In terms of the scope or deliverable coming from the Alliance, it ultimately ends up being some form of a software specification or even software code that Geneva contributes to the marketplace. And we've seen that the model breaks down fairly closely to this. If you look at an entire head unit that would be described here as the Geneva reference, there is an HMI or human machine interface element to it. Geneva is not really working on that. There are reference applications. Geneva is not really working on that. And then there's hardware, and hardware, of course, is supplied by many companies, including Intel. And Geneva, again, is not focused on that area. But what Geneva is focused on is that platform section, and you could break that down into 80% of the code which can be immediately adopted from the open source community. Quite a nice option that exists there for embedded Linux. So that work was done many, many years and continues to be done. And so Geneva is able to capitalize on that. And then there's a small portion of that code that has to be adjusted or adopted, or adapted, I should say, to make it more suitable to become an automotive component. And then there's an even smaller portion, say 5% of the total, that has to be developed from scratch. And this has to do with what's really inside the vehicle infotainment system. So if you drill down into that box where we show the Geneva platform, it's broken into components or sections that have need of attention by the Geneva Alliance. So what we've done is we've put together some expertise from the membership. And the expertise can be grouped into these different areas. Again, some areas are more robust than others in terms of participation. Geneva is a volunteer organization. There's no commercial benefit coming out of the alliance itself, per se. So we try to make these activities very attractive for the teams to work on. And the three areas that we found most valuable to the membership is to organize themselves from the point of view of their requirements. So system requirements, the platform requirements, teams of experts will get together and they will plug in those requirements into effectively, our funnel. We've broken those groups into what are called Geneva expert groups, and they are organized by topic. And they do two things in those expert groups. One, they collaborate on what are the common elements between the companies. So you may have 3 different Tier 1s, 2 different OEMs, all in the same room together saying these are the things that we all agree on, and then those that we don't agree on, we'll keep them out of this room. And they will plug those into the Geneva working model, which ultimately comes into a statement of compliance. That's the end goal for the alliance, is to define a statement of compliance. At the same time, which is this area is a little bit different than most industry alliances, the expert groups actively participate and encourage the creation of code projects. Now, in the very beginning of forming Geneva, it was thought that we could manage all these code projects ourselves, and we would have developers and we would be writing things. But the task of that work turns out to be a whole lot more than one might have expected at first. I heard the question earlier about an application store. My observation is that all the car makers would love to have an application store. But when they first conceive it on a whiteboard, it seems fairly simple. But when they actually try to work it out through the mechanics, it's a very daunting task. So what Geneva has done to try to accommodate that scalability is to work with the open source community that already exists outside of Geneva in many cases. And there's a very good example of a project that we think is a good crossover between Geneva and some non-members. Some of you may be familiar with the Ford Sync program. Well, Ford wanted to open that model up so that others could participate, really so that the whole industry would have a consistent way to get to the phones, and so would Ford. And so they created an open source version, if you will, of the Sync project, and it is called Smart Device Link, SDL. Now, SDL is one of several different ways to interconnect your phone, and there's no statement per se that's uniformly agreed upon that there's only, one best way. There's certainly competition in that world. But the interesting thing is that when Ford decided to make their code publicly available, they hosted it in a Geneva open source code project. So even though Ford is not a Geneva member, they hosted their project on the code repository that Geneva maintains. And the benefit of that is that it attracts a lot of other developers. They look at Geneva as a neutral place to do the work, and also they are interested in tapping into the number of Geneva members that are actively involved. There's another team called the System Architecture Team. This is led primarily by the participants, or let's say the leads of each of the working groups. And they settle in on what are the most important characteristics of this aligned requirement mix that should pop out at the bottom as a compliance statement. And then once a compliance statement is defined, there's another team that assembles those components into a baseline. And a baseline is somewhat of a recipe of how to build a Linux stack. So Geneva maintains two different baseline technologies. One is called Yocto, the other one is called Base Rock. And using these two baseline technologies, any software developer can create a Linux embedded system, a complete operating system distribution, with the assurance that it will be compliant with the Geneva compliance statement. So in many ways, the process has been simplified, it's made a lot easier, and over the course of the last several years, we've really improved that flow. So those members, every member really can have an open source distribution that they manage or that they maintain, and those result in some form of a compliant product. A compliant product doesn't necessarily mean a car, although ideally it will. It'll represent a significant portion of the code in the car, no doubt. But the members are the ones that can offer up their compliant products either to other Geneva members or to the public at large. Some of our members are offering their Geneva compliant products to car companies that have no idea that they're getting a Geneva platform. They simply are looking for effectively a black box to meet an RFQ. So it's an interesting flow of work, and how it's been working. It's definitely been improving over the years. I thought I would show you, though, just a glimpse of what the complexity of the compliance statement is. It is a pretty substantial piece of work. These different boxes represent individual Linux components that either existed or have been modified or recommended modifications to suit the needs of the automotive platform. And depending on the shade of color or green here, they may have more of a higher level prioritization within the Geneva compliance statement or a lower level of prioritization. And they may be directly adopted but not necessarily changed significantly to suit automotive. So, over time you may study these components and learn just how they all plug in together. And that's the work that comes out of these expert groups. So I have a tremendous amount of respect for the effort that goes into this planning and into the actual building of a platform based on what would appear to be a very large number of different software components. Going back to just kind of a glimpse of where you go to get to the open source projects. These are all hosted on a public website. So while Genevi does have a membership basis, and you need to be a member to participate in the expert group activities or to be part of the architecture teams, you do not need to be a member in order to access the open source projects. And these are located on websites that are back-end maintained and supported by the resources of Genevi. And I mentioned the 2 baselines. Those are also listed there on those public sites. We do some analysis to try to assess what kind of popularity we're seeing in the projects. And some of them are quite impressive in terms of the number of code contributors. And it's really part of the open source process is an interesting dynamic, how the word gets around, how popularity of a project can be stimulated based on how interesting it is, not necessarily what the code looks like at that point, but what the code could look like. So we found some pretty good results in publishing and promoting these Genevi repositories and getting developers signed on. Also, when it comes to hardware, Genevi's platform is suited to be open, and all of the companies listed here are participating in a availability program so that hardware boards can be ready to go pretty much to demonstrate a Genevi platform. So these are all embedded device types, all suitable for reference implementation for automotive. We also had a recent article that we were kind of amused by, because I don't believe that anybody from Genevi was interviewed too heavily for this article, and yet the publishers of this German newspaper chose to single out Genevi as being one that is easy to start with or easy to work with. And when it comes to code development, that's definitely important. So we've had some great successes in the last couple of years on making Genevi easier to work with. I also heard a little mention of some of these other industry alliances. Genevi has working relationships with about a half a dozen different automotive-related industry alliances. You see the Linux Foundation with automotive-grade Linux there. That organization is more focused on the code side, whereas Genevi is more focused on the middleware elements of the code. So there's both a broad and a narrow focus between these organizations. The W3C, interesting one there is that W3C hosts a project to publish or define the APIs that will be used to consistently communicate between applications in the car and the car's vehicle bus. And by making those applications more available to web developers that are using web tools like HTML5, that's going to advance the marketplace. That's not a scope that Genevi's particularly active in, but what happens with the W3C Alliance is that Genevi has joined the Alliance and has allowed up to 4 of its members to participate in the working sessions of that team. So Genevi has influence over those standards. In fact, we probably have more than half a dozen companies that in one way or another are contributing to those W3C Automotive Working Group expert activities. And they have, I believe they're very close to publishing, or maybe have already published some specifications for developers to use. But usually by this point in the talk, people are interested, well, what's it all about? What does it mean? And we certainly started out the program, with Intel and BMW, working to try to break through this new model. And BMW was the first to commit that they would bring an open source platform into the car, and it would be going into series production. They actually discovered a few learnings, and while we projected that there would be about an 80, 15, and 5 model of the use of code, it turns out that there was more unique code that needed to still be created. So the created code had to be developed inside of the development project. And so what we're trying to do there is reassess, well, is that 5% where we want it to be? I mean, do we really want the Geneva Alliance to be trying to create 27% of the code needed for an infotainment platform? It's one thing to create the code, but it's a whole other thing to maintain that code. So we're working to try to enhance, let's say, the suitability of the code that's out there. And one of the ways that we intend to do that is to step up on a couple of areas for investment in 2014. So I'll just take a minute on this slide because the point I was just making relates more to the second bullet in the sense that we learned some things about software components that entered into production planning that needed to be enhanced. So one part of the funding that Geneva has access to will be investing in code development that not just the Geneva members, but also other members will have, or non-members would have access to. Also, there's been, as most of us on the call are aware, many developments since the beginning of the year about car integration with phones, and Apple and Google making themselves present more notably in the car. We believe that Geneva can participate in that dialogue. And so we're going to be sponsoring some integrated solutions, some software components that are suitable for use in the Linux environment in open source that will make it easier for a car manufacturer to offer to its customers both Apple and Android interaction with the phones. And not so much to take away from any of the work that's been done there before, but to make it easier, to make it simplified, because we believe that it's got to be more straightforward and it's got to be more efficient because the costs are just simply too high. The cost of developing automotive platforms is not generating enough revenue for the car companies. It's simply a cost. So those are a couple of the things that we're focused on in the coming forward year. I think that you'll be able to observe that both from the outside, and if you're already involved in Geneva, you might see some of those things rolling out. If you're not involved in Geneva and you'd like to be, it's very easy to look up the information on the website, of course, and then you can reach out to myself or some of the other folks in the marketing group to see if there's a way that you could participate. So I thank you very much, Francesco.
Okay, thank you very much for this interesting presentation. We are quite late on the agenda, so I will ask only for one question, if there is one question, the others at the end. Is there any specific question? The first question will be the one selected, if any. Okay. There is a question from Lawrence. Let me check. I will try to read the question just to save some time. The question is, what about the allocation of spectrum? Is there room for a massive network that is using such a large amount of frequency through LTE? Will it disturb other outside communications which aren't in vehicle?
Yeah. Francesco, I'm not sure if that question was directed to me. Yeah, I might be able to share an opinion on that, but I don't think it's really relevant to the work of the Geneva Alliance. Geneva Alliance is, like I mentioned before, focused on software development. Now, the implementation of things like connected car, connected vehicle, those areas still exist from Geneva's point of view. Those areas are differentiating features for the automakers to put themselves aside. And Geneva's not trying to take a position on standardizing some of the more finite elements of the user experience on a connected car. What we're trying to do is get rid of some of the overhead so that you can move into those spaces and solve those problems independently. So I'm not sure if that question was really directed to me, but I don't have a really great answer about the spectrum.
Okay, thank you. We can take again this question at the end of the webinar. Thank you very much, Joel. So let's go to the next. Okay, next in the agenda is Ryoki Kawada from KDDI Corporation. I will open your microphone. Okay, Ryoki. And I will open also your presentation. Okay. Let me try again. Okay, for some reason I'm not able to show the you should see the presentation on the screen, not in the slide presentation mode, but I think it may work the same. So Ryoki from KDDI, welcome. Ryoki received his degree from the Tokyo University in Japan in electronic engineering. From 1991 he was with KDDI Research and Development Laboratories in Japan. He was engaged in the research and development of video processing, especially motion compensated frame rate conversion, video quality evaluation monitoring, video coding and recognition. In 1997 and 1998 he was a visiting researcher at the Center of Telecommunication Research in Columbia University in New York, and currently he is with R&D Strategy Division of KDDI Corporation, as well as a senior visiting researcher in Keio Research Institute at SFC. So welcome, Ryoki.
Okay, my name is Ryoichi Kawada. Thank you for inviting to this webinar. I'm very happy to be here. Today I would like to talk about our prototype system, HTML5 based in-vehicle infotainment system. Next slide, please. Okay, this is the concept image of connected vehicle services with in-vehicle infotainment system. People can access traffic infos and maps, internet radio and social media, health and medical support, home energy management system, and also building energy management system, and ecological control, and even personal life log bank. In addition, public safety answering points and emergency management agency should be easily accessed. So the typical mashup applications are internet radio, SNS, intelligent navigation using probed data such as speed or position, driving assistance including parking and alerting, drive record and diagnosing. Also, pay-as-you drive insurance, driver abnormality detection, emergency call, and so on. Our prototype assumes that IVI and the smartphone collaborates to realize these services. Other models include one where all the task is done by IVI and one where a smartphone does all and IVI only works as display, but our model assumes that IVI and the smartphone collaborates. Next slide, please. So to realize this concept, in-vehicle infotainment should be able to load data in a smartphone, such as navigation route history, maps, music, video, and so on. And also IVI should be able to utilize devices inside the smartphone, such as GPS, camera, and sensors. And also, it should be able to get smartphone status, such as battery and communication status. And also, it should be notified by the smartphone of call arrival, emergency notice, and so on. In special, arrival of calls and emails to the smartphone should adequately be notified to drivers via IVI, considering the driver's status such as driving or stopping for traffic lights. And also IVI should be personalized. Also the next slide, please. So this is an example system for the pair of IVI and the smartphone which realize the concept. Later I will show you a demo. Here, smartphone acts as a web server and IVI contains HTML5 browser. IVI loads web apps and data from the smartphone. By this scheme, we can personalize IVI by smartphone and use various HTML5 applications and resources in the smartphone via IVI. There are web servers in the smartphone, and IVI can utilize the smartphone's resources through the servers, which are RPC server, WebSocket server, HTTP server, and SSDP server. For example, IVI's HMI and web apps are loaded from the smartphone. The browser in IVI has Vehicle API, which is connected to CAN, controller area network in the car. Simple Service Discovery Protocol, SSDP, is used for the discovery for this prototype. Okay, next slide, please. So this is a use case of HTML5 based IVI. For example, when IVI and the smartphone are both connected to Wi-Fi inside the car, IVI automatically detects what is in the smartphone. Destination can automatically be set on the IVI based on the information in the smartphone. And also, music in the smartphone can be played on the IVI. Next slide, please. This is our second use case. While the driver is driving the car, his friend can set a destination on the IVI by using her smartphone. This is realized by the WebSocket server on the driver's smartphone, which relays the information from the passenger's smartphone to the IVI. Next slide, please. Also, the look and feel of your IVI can be customized to each driver. It is loaded from his or her smartphone. Okay, next please. This slide shows the detailed architecture of the smartphone server and the IVI. IVI calls smartphone's APIs transparently to remote navigator interface. Next, please. There's a similar thing, mirror link. This slide shows the difference between mirror link and HTML5 IVI. In mirror link, all the applications run on the smartphone, and the display only receives the results and shows them. So the high processing power is required for the smartphone, and the rate for transfer from it to the display is high. On the other hand, in case of HTML5 IVI, applications run on IVI while contents come from smartphone. Therefore, balanced computing is possible, and data transfer is relatively small as well. Next, please. In World Wide Web Consortium, W3C, there's a business group named Automotive and Web Platform Business Group. It was created in 2013. Last December, an official draft of Vehicle Information API was made, and they are working on that currently. Next, please. So these are the BG members. And also from Japan, Jarian Jada is also a member. Okay, that's the end of my slides, and I will give you a video demo. So would you please give me the control of the presentation?
Yes.
Okay. So the center one is supposed to be IVI, and a driver brings his smartphone inside the car. IVI automatically detects smartphones in the vehicle. So the name is appeared. So this is the passenger, his girlfriend. IVI is being associated with driver's smartphone by tapping it on the screen. Now the IVI automatically looks for the route to the destination set beforehand in the smartphone. In case of long distance driving, his girlfriend's smartphone would get recommended to other waypoint for longer driving. So the places and the information of waypoints are displayed on IVI and her smartphone, respectively. So they're stopping by some restaurants. Then his girlfriend is handling her smartphone, and the route is arranged to have a waypoint chosen by her. So the IVI shows the route including the waypoint. Now every driver can configure appearances and functionalities of IVI as he or she prefers. In this example, the look and feel of the IVI is customized to his girlfriend's smartphone. And also, IVI can play any music content stored in all the smartphones in the vehicle. Okay, that's the end of my presentation. Thank you very much.
Thank you very much for your presentation. So let's open the floor for one question. The first question, if any. Okay, Seth has a question. Seth, I will open your microphone if I'm able to do it very quickly. Yes. Okay, Seth.
Thank you. Great presentation. Thank you. One of the things I observe about the KDDI presentation, there seems to be, and if I'm interpreting it correctly, kind of a significant difference in the approach that was described in the first presentation from Russell, where the in-vehicle systems seem to be the controlling devices, and in the KDDI presentation, the smartphone is the controlling device. So my first question is that actually a valid observation? And if it is it a significant difference in architectural approach, or is it something that can be harmonized between sort of the two speakers' approaches to how in vehicle or the cars will be connected. So thank you.
Yes. Yeah. Thank you very much for the question. I think yes, it looks different, but our approach, also the IVI can control the smartphone also, because it is it is HTML5 server-based application. So smartphone can control IVI, and also IVI can control the smartphone's contents if we wish. So our demo is only a prototype demo, so for HTML5 based control. So I think we can arrange the actions according to the according to the preference we are going to make in some meetings, or such as WCC meetings or Geneva meetings. So it's just a technical demo.
Okay, thank you very much again, Ryoki, for your presentation.
Thank you.
Let's go to the next. Next in the agenda is Sanil from Smith Micro Software. Let me open your microphone. And let me open your presentation. Okay, Sanil is currently, welcome and thank you for accepting to present in this webinar. Sanil is currently Vice President of the Product Management for Smith Micro Software, in charge of product strategy and roadmap for the wireless and mobility product. Prior to Smith Micro, Sanil led the product management and marketing functions at the HP in their Mobility Solutions Group. He also held the position of Vice President of Product Marketing and Pre-Sales at Bitphone Corporation, where he pioneered in the market definition and technology strategy for over-the-air device management solution, including firmware update and remote diagnostic. Sanil has co-authored several industry papers on operational challenges and best practices associated with the support of complex mobile devices, including key contribution into industry standard bodies such as the Open Mobile Alliance, OTE Flash Forum, and the CDMA Development Group. Sanil holds a BSEE from the University of California, Los Angeles, and an MBA from the University of California. So, Sanil.
All right. Thank you. Thank you for the introduction. I'll try to make it quick. I know we're running behind schedule. We are taking, I think in this view, a slightly different approach here in terms of what we're presenting today. While many of the presentations have focused on the consumer view of the connected vehicle, I want to present the case for commercial vehicles and use of standards and connectivity across commercial vehicles. Next slide, please.
You can control the presentation,
I
Sanil.
control. Okay. Yes. Let me see how to. where are my controls? Francesca, I'm not seeing the controls. I'm not sure how to control that.
You should see an advice. Otherwise, if it is okay for you, I will take back the control and.
Yeah, go ahead. I'm just not seeing the place where I can control that. Okay. So I will quickly kind of give some background on Smith Micro. We are a 30-year-old software company, actually older than 31 at this point. We've been primarily developing software solutions for telecom. So our customers are major wireless operators worldwide. For connectivity, policy on device, including device management, as well as messaging. So we've got quite a strong portfolio across the board. Next slide, please. And I want to just quickly give some references here in terms of what we've done with our innovative device management. In the automotive area, we worked with GM to produce a solution that would help reduce service time and provide preventative car service. So this is based off our OMA DL solution that got deployed in GM service stations. So when vehicles are brought in for service, they automatically connect, looking for new firmware, software updates, as well as collecting diagnostics that can be used to help service that vehicle. On the telecom side, we've deployed this platform, again, based off OMA DM to help reduce network congestion. So policy on device being used to do network selection, radio management, and provide seamless connectivity across Wi-Fi and cellular. And then we are also doing things within vendors for network optimization. We are quite familiar with OMA. We've worked well with that group. But there's also management objects being developed outside of OMA. So, for example, 3GPP created this ANDSF management object. And what we've done is try to fill the gaps there between the two organizations to provide testing tools and make those available to vendors for helping to validate interoperability. So we've currently announced that Amdocs and OpenNet have both gone through that program, and we've got other vendors in the mix as well. So it gives you a little bit of information about the breadth of device management and the areas we play in. Next slide, please. So this is the baseline of the platform. I'll talk about the application of this into the connected car in a moment, but just to give you an idea, it's based off of three key components here: the policy management server, which is based off OMA DM, a intelligent client that actually can be retrofitted to different applications here that features a programmable rules engine, policy on device, can support the standard firmware software update functionality, support security authentication, as well as intelligent network selection. So those are some of the key features, but as I'll mention in a moment, that it's quite an extensible type of platform. So I'll show you in a moment how we've extended that to support additional use cases. And of course, on the back end, a reporting and analytics server to collect data. And then can you go ahead and build out this for me, please? And you can build it, I think, 2 more times here, 1 or 2 more times. I'll keep you posted here. Yeah, 1 more. And so overall value, reducing complexity and cost. So, working with operators and trying to help them to build their value proposition within the connected vehicle and M2M spaces, providing a platform that, can leverage existing standards that they've already invested in, and being able to extend that, and working with partners to build on top vertical applications, interoperate with device module makers. And so that's how we go to market. And in this next slide, I'll show you how we've applied this in a connected car scenario. So next slide, please. So this is based off a proof of concept that we demoed at Mobile World Congress, and we were invited with OMA to do this in their booth there. And the scenario here is not a consumer car, but a commercial vehicle. So this could be a taxi or a car service with a M2M module built into it that has its own Wi-Fi network. That module is connected over the air back to management server and central dispatch that controls policy. And go ahead and click one forward here for me. So we've actually extended this. Although OMA DM is commonly used and thought of as asset tracking and basic device management, it can be used there, but I want to introduce some additional extensions that we've created to help monetize this. So one of those extensions includes the ability to push relevant content over this standard. We actually have defined a management object that supports HTML5 pages that can be preloaded and pushed to the M2M module in the vehicle. As passengers get into the vehicle, there is mounted digital signage as well as the ability to bring in their own cars and connect via Wi-Fi to this. And that content through a capture portal is available and refreshed over that protocol. So this provides relevant content. It provides relevant promotions that can be monetized. And using trap mode, we can actually capture that user interaction. We can also trigger contextual offers, meaning that the promotions that we provide and show can be based off location, region, can also be based off passenger ID from the mobile devices themselves. All right, next, please. In addition to those promotions, we're able to support the building of customer loyalty. So because the passenger devices have signatures with them, either through their MAC address or their Bluetooth ID, we're able to actually look at and understand passenger traffic, to understand if this passenger is a repeat passenger or considered a high-value passenger that needs further engagement. Through this interface, we can also promote the ability to push a downloadable app that would allow a taxi company to provide ongoing value even outside the cab. So this really helps with competing with new services emerging, things like Uber, but providing that Uber experience along with the ability to also track these passengers as they come in and out and use that taxi service in different parts of the world. And so again, that's captured because these devices can be identified by the M2M module, which can then put that data back in through an analytics server at central dispatch, which can be mined for understanding the passenger and loyalty. Next, please. And then the next one is using the M2M module itself that's out there on the devices to actually do fleet tracking. So being able to, again, monitor different parameters that are collected from that device. We're able to collect key performance indicators that would provide indications back regarding driving behavior, be able to provide optimized routing, and improve dispatch efficiency, which can also save in fuel costs. So understanding and using the same system to actually be able to do fleet tracking, whereby you're basically deploying and dispatching the right vehicles to the right area to optimize routing. And the next build, please. And this got cut off a little bit, but the final one is the classic device management. So in addition to those other areas which provides better efficiency, provides monetization opportunities, of course you get the standard device management, being able to monitor the M2M device health, refresh the software, firmware, and push new capabilities out to that device. And so in this example, you can kind of see how we've been able to leverage existing standards, things that have already been invested in, but then extend those things to be able to monetize through promotions, improve customer loyalty, and optimize with fleet tracking. All right, next. And in this next slide, you can also see how this concept can be extended to not only taxi but exterior vehicle monetization, so location-based signage, digital signage on buses, on taxis, in-vehicle ads and apps for access. So that module is also its own Wi-Fi router. So sponsored data, providing Wi-Fi access on buses and trains can also be monetized and also be controlled. So in our proof of concept example, we were able to provide not only sponsored data, but we were also able to provide a charge service. So especially if you're a tourist traveling internationally, you don't want to turn on your cellular. You might be in a cab. You want to quickly check your emails. You can get some sponsored data, 15 minutes, and quickly check your emails without paying those international roaming charges. And then we mentioned a little bit about the concierge service in and out of vehicle through a connected app. Next. So that's the introduction of the concept. I just kind of wanted to touch upon that and show how leveraging some of the investments in OMA and leveraging those OMA DM standards, but providing the right extensions can help turn that in from just kind of a management vehicle to really a monetization vehicle. And I've provided my contact information there if you'd like to follow up with any of the concepts that we discussed here, want more information. So thank you for that.
Thank you very much, Sunil, for your very good presentation. So open the floor. I will open the floor for one question. The first question for Sunil. Okay, I do not see a question probably for the end of the webinar. So let's go to the next. Thank you again, Sunil, for your presentation. Next in the agenda is Yoram. Yoram from Red Band. Yoram, if I remember well, let me open your microphone. Hello, Yoram, you prefer to take the control for sharing your screen, am I right?
No, you will control the, you will control the presentation. You will continue to do your great job.
Okay. Okay, thank you. I will. So let me open the presentation of my laptop. Let me try to share. Okay, it's working. Okay, welcome also to you, Yoram. Yoram is the Director of Marketing Adoption at Red Band Software, the market leader in mobile software management. Yoram is responsible for working with mobile operators and device manufacturers to help them increase and improve their usage of over-the-air software updating. In addition, he has the responsibility for developing partnership and go-to-market strategies in the automotive and connected device markets, and oversees the Red Band certified OMA interoperability program. Yoram has experience in engineering, product management and partner management with an emphasis of mobile technologies, having worked at Motorola, Pelephone, ECI Telecom, Schema, Intel and Marwell. So, Yoram, is your turn. Thank you.
Thank you, Francesco, and thanks for the OMA to have the opportunity to present here. A few words about Wedband. The company established in 1999. It's a private. We are serving the mobile industry, enterprise mobility, automotive, and Internet of Things. Our product installed on more than 2 billion devices, such as smartphones, tablets, cars, M2M, and Internet of Things devices. Can you move the slide forward, please? I also will shorten my presentation, and I will emphasize on the impact of the software on the automotive market. As we all know that the software is increasing inside the car, like in the movie Perfect Storms, where few low pressure storms combine together. Here also there is the impact of connectivity, the increase of software, and the electrical car. All of that is transforming or moving the car industry much faster forward than the previous years. Next slide, please. As we all seen both in CES and in Mobile World Congress, events that usually are not got a lot of automotive presenters. This year and also in the last year there is a lot of change, and we can see that the car manufacturers are presenting all the new function and features that most of them are based on software, as you can see here in the information in this slide. Next slide, please. And you can continue until the... So, when I say software on wheels, there is a lot of means for that. First, most of the no, go back please. Okay, thank you. Most of the innovation today are based on software. As it was presented last year in the in a conference of AutoSAR, about 90% of all the innovation today are done by software, and they anticipated that by 2020 about more than 99% will be based on software. About 40%, more than 40% of the bill of material of the car is already based on electronic and software, and in some cars there are more than 100 ECUs, the controller that exists inside the car. Not only the number of ECU, but also the amount of software is increasing, and the lines of code in today's car can reach between 40 to 100 million lines of code, much bigger than other industry. And the impact of the amount of line of code is on the amount of error. So if we are considering NASA as the institute with the lowest, with the highest standard of quality, where there are about 0.1 error per 1,000 line of code, and in commercial product like a TV or set-top boxes or handset, there are about 50 errors per 100 line of code. We can understand that even in infotainment system and ECU, the amount of error is increasing because the amount of software is increasing. A side note for that is also the security, because the fact that the car is connecting to the cloud, it means that malware and viruses can be penetrated into the car, and there were several tests and demos that the companies show how they can penetrate into the car system and influence that. But going back to the errors, we can see already today that about 60% of the recalls today are because of software. As Russell said in the first presentation, this is impacting the bottom line of the car manufacturers, and there is no reason why those updates will not be done over the air like in the other industry. Next, please. And can you hit in the button here? Yeah. Okay, never mind. So basically, the Elon Musk, the CEO of Tesla, he said about a few weeks ago when there was an issue, a recall to its car because of software, that this is not a recall, this is a remedy because they can fix all the car over the air because they have all the infrastructure and all the function to do that. And this is the reason why after 2 days they fixed all this issue over the air. So again, he said this is not a recall, this is a remedy. And I expect that most of the car manufacturers today will follow up on Tesla, and in the coming years they will implement it. There are already some car manufacturers that are doing it in a very small scale, but in the near future most of them will do it a large scale. Next slide, please. So software update can be done in any place. So inside the production, in order to save time when car manufacturers are programming their ECU. In the post-production, after the car is, and before the car is shipped to the target market, and there is a time where a new software can be arrived. In the dealer, in order to save the time that customers are bringing the car to the dealer, and then after 2 to 4 hours they can pick the car. When doing it over the air, this time can be saved dramatically. And at home, of course, where there are already a car manufacturers that are doing some way of letting the user to do the update with the discount key, but this method is not safe. This method consumes a lot of time from the user. This can be done over the air without all the hassle of taking the car to the dealer or perform it manually. Next slide, please. So there are basically two main challenges how to car manufacturer will manage the software version, which of course it's not like they are managing hardware parts. And second, how can the industry manage the software in the most convenient and effective way. Next slide, please. So there are, and as we hear from Mr. Kawada from KDDI, there are already operators that are using their knowledge and expertise in order to penetrate also to the automotive market. We heard about AT&T Drive Studio, we heard about Sprint and Chrysler and Vodafone and BMW and more. So there are a trend of the operators, the mobile operator, to get also to the automotive industry and not only to sell the SIM card, but also some add-on services and activity that they can use their infrastructure. Next slide, please. So basically, the solution of Red Band composed of two main elements. The first one is the server side, which manage basically the whole process. In the server side, there is all the software generation, where the secret of Red Band is to take two software versions and extract only the differences between the version, and this will be sent over the air, and this can be applied on both firmware and application. This can reduce the size of the package by 95%, which is very important to reduce both the data charges and second, improve the user experience when waiting to download the package. And in the car, there are two main clients. The first one is the communication client, which I elaborate later. And there is the update agent that can sit in both the head unit and on the ECU and enable to update holistic the car software even in the most remote ECU. We choose in Red Band to work with the OMA DM as the protocol between the server and the client because several reasons. First, it's very suitable for a wireless environment, for if it's a cellular or if it's a Wi-Fi. Second, inside the genes of the OMA DM, there are some elements of security, like MD5 for authentication, HMAC for integrity, SSL, TLS, and more. And lastly, there are the built-in management objects such as the FUMO, SCOMO, and LOMO that can be used for updating a part or whole amount of processors inside the car. One of the benefits of Red Band solution in terms of the client that our client also can be incorporated in a very resource-constrained environment like ECU with a small memory footprint. Our client can go lower than 10 kilobytes. So this is a great benefit that with one solution you can update the whole car component. Next slide, please. This is an example of how OMA DM SCOMO can be used for updating the car. So by using the SCOMO, the software inventory can be taken from the ECUs and delivered to the server. There are dependency management, meaning the order of the update is very important in some of the cases, and SCOMO is supporting that. Installer independence, if it's working with the Genevi or with QNX or with Linux or with any operation system, it can use their installers or other installers, it doesn't matter. There is ability to combine multiple software updates in the same package, meaning you can put in the package the update for the infotainment system together with a few updates for the ECUs. And there is a client-server independence and interoperability because it's a part of the OMA DM. Next slide, please. So, to summarize, software update is and firmware update is essential process in the new car that are now in the market because the increasing amount of software. The OEM can benefit from a small reduce the amount of recall and reduce the time to market in order to bring the car. The operator can achieve the operation of those services using their existing OMA DM infrastructure, and the consumer will get a better driving experience by updating the car with the new functionality and the new feature, together with the ability to update bug fixing without the need to go to the dealer and will cost him in time and effort. Next slide, please. Thank you very much, and if you have any question after this session, you can send me an email to yoram.berholz@redband.com. Thank you very much.
Okay, thank you very much, Yoram, for the very good presentation. We ran out our time. Sorry for this, but it means that the discussion, the presentation were very good. I would go directly to the next and last presentation, and then we'll ask for question if any. The next is a presentation from Sean Fleming from Information. Sean, let me open your microphone. Okay, Sean, your microphone is open. If I remember well, I will show the presentation using my laptop. You will take the control. Am I right?
No, you'll take the control, Francisco. Thank you. You've been doing a great job driving.
Okay, great. Thank you. Okay. View. Let me open the file. Okay, should be on the screen. Sean Fleming is the Vice President of the Business Development Worldwide for Information. He is responsible for all of Information's strategic alliances, channel partners, and OEM relationship. He has previously served in various roles within Information, including solution sales, pre-sales, professional services, and customer support. Since joining Information in 2004, Sean has proven track record in building world-class pre-sales and services teams, as well as deep customer relationships through strong pre-sales and post-sales support. Prior to Information, Sean was a management consultant in the communication and media industry sectors of IBM, PricewaterhouseCoopers, and Andersen Consulting, now Accenture. Sean has led implementation teams for various Fortune 500 companies. Sean holds a BS in electrical engineering from the University of Delaware and is also an EIT registered in Delaware. So thank you very much, Sean, for accepting the opportunity to present, and it's your turn now.
Thank you, Francisco, and thank you to the OMA body for allowing Information to participate. We appreciate it. You can go on to the next slide. And I think you just might have skipped one. Previous, I'm sorry. Okay, well, I'll jump in. This will be pretty quick. Information has a broad solution for device management, ranging from the simple endpoints to the complex. We've been involved in device management since our inception in 1999. We are a private company. We've made various direct and indirect contributions to the standard, being able to help propel it and gain faster market acceptance. We have a solution that's been designed to be multi-tenanted and headless, and while the solution is standards compliant, it also has been hardened after more than a decade of Tier 1 carrier installations around the world. It's also been benchmarked to process millions of transactions per day with live traffic. Information has a highly scalable, you can stay on the slide, thank you, has a highly scalable, you can go back actually. Information has a highly scalable cloud solution for M2M device management. It can easily serve multiple industry verticals from automotive to the digital home. It leverages the OMA standards, and I think we heard just before about some of the various management objects that can be used as a base protocol for communication, but it also has numerous layers of business logic, automation, web services, reporting to support additional use cases and value to our customers. The server can diagnose, configure, and update devices directly or indirectly as when it gets to what we call area network management. Next slide, please. And I think we might have skipped the slide here, but if you could just advance, I just don't see the slide that was expected here, Francisco. Oh, you can go back. Well, the OMA standard is rapidly becoming quite pervasive in this industry sector, due in part to the evangelism and success in adjacent telecommunication markets around phones and tablets and CPEs. There are over 1 billion devices using FUMA alone, the firmware update management object that we were just discussing in the prior presentation. And while that has historically been very important in the past, other standards are now evolving. SCOMO, Diagmon, DCMO are now evolving to enable broader lifecycle management for complex software components on devices, including application management, security patches, radio modem software updates, and configuration management. OMA DM has gained a level of acceptance in the automotive environment. The head units, as you've seen in some of the other presentations, are now becoming OMA DM capable. The standard's always expanding, and a capable lab environment or partner can enable rapid activation of new management objects and capabilities. And this all allows for DM to solve the key issues for today and tomorrow, from the vehicle head unit to wearable devices. Next slide. So we see that before, everything from our perspective was on the phone, and this was a simpler environment. And now with the explosion of various connected devices, especially the automobile, the complexity has exponentially grown. The automotive sector is one of the key users of M2M systems, with a typical car potentially using hundreds of different software-driven components. Now, not all of these are critical today, but it's expected that over time, the criticality of those systems will increase. Some of them will be critical insofar as a consumer will be accustomed to their operations and usage to the extent that their absence will make that person feel uncomfortable. And this is similar to mobile phones today. It's anticipated that the car will augment the view of the driver with navigation, environmental information, and entertainment. Additionally, the bidirectional communication in the car will be voice recognition and synthetic speech. This reliance on this augmented reality will increase over time as more systems are added into the mix. And the car manufacturers are also going to use this standard and use the server to pull back performance information on their components independent of the consumer so they can continuously improve on them and obviously improve on the experience of the end consumer. Next slide. The number of critical systems in the car is expected to increase. These systems will typically be designated as business critical, safety critical, and security critical. Business critical refers to things such as automatic toll payment, pay-as-you-drive insurance, and automated parking payment. Pay-as-you-drive is particularly critical for the consumer as it may not be possible to use the car unless this is activated. Now, there's a need for improved efficiency and time management. For many, the vehicle is a mobile office for appointments and meetings, etc. The prosumer and the consumer will need the continuity of information from the fixed office to the vehicle, from the mobile to the vehicle. And competitive advantage is going to be held by those with faster access to the information grid. To ensure this, the automotive environment must be constantly and correctly maintained. The appropriate and timely configuration, application, and firmware provides and enables this business edge. However, it's not solely the OMA standards that enable this, but the intelligence of the platform to take numerous factors or variables into consideration, from software attributes and dependencies to other priorities. The safety critical systems are automated 911 services like the emergency call that was discussed, I think, in the first presentation, and E911. Other safety critical systems, braking management systems, autonomous driving and collision detection, and plus many others, some of which may not appear safety critical at first glance. For example, the automatic seat adjuster, but in operation while in a driving motion certainly is a safety critical item. So not only are these systems critical from a safety perspective to the consumer, they're also business critical to the manufacturer, who's going to be liable for a failure and want to avoid costly recalls. The safety criticality was not always present, especially in the mobile phone environment. Keeping the vehicle up to date with the latest updates from temperature modules to navigation systems can potentially save lives. The determination of the right software components for the right module at the right time and sequence are decision points that were not previously over-the-air managed or available. And this can be applied to safety devices, child monitoring systems, and various other components in a connected home. All the OMA standards that may have had a bit more limited rollout success in mobile will now be more required and at the forefront in telematics. And I'm referring to SCOMO, the software component, management object, and DCMO, and so forth. Security critical systems are items such as biometric car locking, anti-hijacking, and vehicle location. And these may be critical insofar as the consumer will not want to use the car if they're not functioning effectively. All these systems, just like the mobile phone today, will need managing, and the more critical they are, the more they'll need that management. The huge number of different and varying components makes the management of them and their interdependencies a challenge in and of itself. So now this is the time for augmented reality, where this virtual world and our physical world are obviously coming together, and machine-to-machine communications are facilitating our convenience. Instead of carrying around the world on a device, we have devices throughout our world. They're everywhere. They're in our vehicles. They're in our phones, in our homes. They're monitoring our vehicle's tire pressure. They're tracking our driving habits. They're uniquely and personally connecting us to the people and places and things that are our reality from virtually anywhere. But the devices that do this augmentation are not necessarily smart. The sensors in our cars, for seat belts and locks and brakes, are simple, fit-for-purpose devices. The intelligence in our connected world ultimately comes from the way we manage it. Next slide. Thank you very much. And my name is Sean Fleming. I can be reached at sean.fleming@information.com for any questions.
Thank you very much, Sean. So I will open the floor for a couple of questions. Please write your question and also indicate if the question is for a specific speaker. Kenny Kwong, if I remember well, you raised your hand for a question. Do you still have your question, or is somehow answered from the presentation? Okay, Kenny, you are muted. You should unmute yourself.
Okay, you can hear me. I can see that. Thank you, Francesco. My question was a simple one to the first speaker. I guess that was perhaps looking at a very large landscape for introduction, because I was going to ask whether there had been any or will be any particular issues, identification issue being identified for further dialogue and investigation with OMA. Whether that was just kind of describing the landscape to the OMA audience.
So your question is for Russell. Let me open the microphone for Russell. Russell.
Okay. These were the views that I put together from the ITU collaboration and ITS communication standards, where the participants from both the car companies and some of the carriers are very concerned about how really things get put together. A number of them have participated in the GSMA automotive effort, which has concluded with some testing and some ideas, and there's kind of a general belief that a serious cooperative effort needs to be moved forward, particularly as automated driving is on a reasonably close-in horizon now. But we're not saying, and I don't think it's our position, we certainly would like to be part of an effort, but we're not the ones to decide where the effort should be. It primarily has to come from the carriers.
Okay, thank you very much. There is one question from Seth, then we will have a question from Lawrence Doe, and finally a question from Gerson. And that's it. Seth, I will open your microphone so you can directly answer. Sorry, you can directly ask your question. Okay, Seth, your microphone is open.
Thank you. This is questions either for Sean or Yoram, because your presentations and your products concentrate a lot on existing OMA DM, their implementations of the existing specification. As you're looking ahead do you see things that should be changed or added or incorporated into the OMA DM spec, or others for that matter, specifically to serve the automotive market? Thank you.
Hi, this is Sean. I'll go first, and then I'll turn it over to my colleague Yoram. I certainly would think so. I think there is, and please let me know if you can't hear me. I think there is an additional need for the associated metadata around SCOMO and the, or even perhaps on FOTA as well, because it's just a significant increase of parameters and variables and attributes which make these kinds of software updates and managing, pushing them out a lot more complex than I think in the historical kind of single device phone or tablet market. So I think taking in these additional attributes with the device will be more conducive, specifically in the automotive piece, because I think there's numerous dependencies, and those dependencies are based on a wide range of additional factors that previously were more simplified.
Okay, thank you very much. One question from Gerson. I will read the question. This question is for KDDI. So for Kawada, Mr. Kawada, about the KDDI approach. In the KDDI demo, is connectivity also done through the smartphone, also as opposed to the embedded SIM approach described by Russell? Ryoki, I will open your microphone. Ryoki, did you get the question? Okay.
Yeah, would you please repeat the question again?
Yes. In your demo, KDDI demo, is connectivity also done through the smartphone, as opposed to the embedded SIM approach described by Russell? So Russell in his presentation talked about an embedded SIM approach. Your demo, the understanding is that connectivity is done through the smartphone. Is this understanding correct? Is it right?
Yeah, it is correct. So the in our demo, the IVI has is supposed to have only the Wi-Fi connection.
Okay. Okay, thank you very much.
Thank you.
The last question is a question already done to Joel, but probably if someone else wants to answer, is the question, what about the allocation of spectrum? Is there a room for a massive network that is using such a large amount of frequency through LTE? Will it disturb other outside communication which aren't in vehicle? So who would like to answer this question? Maybe
I can take a stab at it, Sunil. We've done quite a bit of work with on the mobile side with regards to spectrum optimization and network optimization. And so I think you can never have enough spectrum, especially with all the demands of the current connected devices, and you add on automotive as well as the rest of the M2M world. So there definitely needs to be some optimization. You know, I think sharing that between licensed and unlicensed spectrum is one approach. I think that has some merit. We've seen some interest around that, especially in the M2M spaces where some customers are particularly sensitive to pricing of the cellular plan. So I think in those cases, if you can use the combination of both, especially on the heavy content media, using of caching and things like that, will help to alleviate that. I definitely think we're going to continue to run into this problem going forward, but you know, I think there are solutions that will help to alleviate some of that we've seen in practice, and that could certainly be adapted.
Okay, thank you very much. This was the last question. I think we had a very interesting, productive webinar. Sorry for the time. We are very late with respect to the agenda, but I think it was worthwhile to go to the end of this webinar. On the slide on the screen, you may see the OMA web page for the OMA events. In the next days, you will be able to find in this page the registration of this webinar and also the presentation that we had today. You may be familiar with the OMA website. If not, I invite you to take a look to have a better understanding of what OMA does, what OMA produces, and in particular there are some events you may see on the screen. One of the next events is what you may see on the screen, is organized in May, UpConnect Auto Conference. So it's an event. The topic is related to this webinar that we had today, and there will be OMA representative, in particular a delegate from Red Band. So you are invited to attend this meeting, but also other meetings organized by OMA or where OMA may be involved, depending on your interest. For any question or whatever you may want to understand better, on the screen you may see some contacts from the OMA staff. So feel free to contact OMA representative for any question, and that's it. This concludes the webinar. Thank you very much again for all the speakers and for all the people that attended this webinar, and see you. I hope to see you at the next opportunity. Thank you. Bye bye.